between dependent variable and independent variable. Is it clear? What is the goal of linear regression? To find the parameter, to find the best parameter which equalize actual value with a predicted value. Is it clear? But problem is, there is okay, so what is exactly problem? Let us do. The question is that how we can find M and C. Anyone? How we can find the value of M and C? The question is again. And let us take. Okay. Yes, basic layman, we know what we did. Okay, slope. What is slope? The rate of change of one thing with respect to other thing. And how we can predict the rate of change? y2 minus y1 divided. What is the line of equation? Y minus y1 equal to y2 minus y1 divided by x2 minus x1, then x into x minus 1. Is it clear? So that is the basic things come for us. But this equation is not good when data is a non-linear. Is it clear? That's why we are going to do the regularization. I'm going to be described. So what is the question? What is the? I saw the little bit thing. So what is the goal of linear regression? That's a very good concept for understanding neural network, for understanding anything, and that is exactly equation of exactly machine learning, according to me. I just saw the thing very clearly. Very okay. Then I do the math and all, and you do the then all the parameter I'm going to be discussing. Okay. Fine. So let us find. This is the thing. We have a lot of data. We need to fit the curve, and which fitting the line we are going to be decide which is the best fit line. Okay, leave it. There's a data. Linearly find the continuous relation. Look like that. Leave it. So what is this? Okay. So we have this type of data. We need to plot the line. The line is known as predicted line, and which is the predicted line which minimize the loss. The line which minimize the loss is called best fit line. The same thing. So our goal is to finding the best fit line. And how take the error? This is the error, that is the actual value. Simple Euclidean distance. You can take any norm. You can take any normalization, no problem. I prefer the Euclidean distance because I have a data. Okay. So this is the thing. So it is your question. It is your time. Tell me x1 and x2. Why? And there is two things. Which one is good for you? First one or second one? Why second one? Yes, because if I take the error, it gives the minimum average. Let us take, okay, how we can calculate the distance? That is called the mean square error. Leave it. So okay. So here, which one is the give the minimum? Which one? First one or second one? Top or bottom? No, first. Because that's why I visualize you. First one give the, we have so many error, but if you sum the error, it may be less compared to it having two error, but the summation of the error is large as compared to the first one. Is it clear? And this term is called the outliers and all. We need to remove the outlier. So what is the goal? Yeah, that way square? Yes. Yes, summarize. Yes. I'm going to be, yes, we are going to, when we do the maths, or I'm going to do the math, you are going to be perform the math. Okay, I just being with me. Just be with me. So what is the goal? To fit the line. Look like that. We rotate the line. We tweak the line until your loss is decreasing. Okay, so I'm not going to be unique gradient descent algorithm. I'm going to be discuss about that after that. But let us take this. This is like that. I'm going to be solve complete math by you. This is means we need to. Okay, but what is the assumption? If you solve this assumption, it means your data, your function should be. Your function should not be monotonically increasing or monotonically decreasing. Is it clear? That is a restriction if you apply the gradient descent optimizer. Means your function should not have what? Monotonically decreasing or monotonically increasing. What it means it must have global minima or global maximum. Okay, so what is the goal? And that is called the weight update. First we update the weight, then we update. But linear regression, this is another thing. This is a back propagation and all. But I'm not going to be for a little bit back propagation. We try to deviate the system, minimize. That is a neural network. The term of the neural network and gradient descent and back propagation come into the picture. But I'm going to solve by basic math, statistics, not by machine learning. Then I show the by neural network. I show that by TensorFlow I try to apply the neural network. What do we try to apply? So what is the restriction? Restriction is your function is take. Function is like that. Suppose your function look like, why I take this function, this type of curve? Why? Because x square. I square down. What is the cost? Cost is square, and we try to minimize the cost function. And what is the cost? Y square. So x minus mx plus c whole square. So we need to, what is the goal? Whenever you are here, we need to come at that point. And suppose you have here, you have a two option, either up, either down. So how we can find the slope? We are going to be which direction? This is given by d by dx. And so the fancy name is a descent. What is the name of fancy name? Descent. So we are trying to descend our error, and but one time here, one time here, one time here. No. Otherwise your error should be, the minima should be overshoot. So that whatever yesterday we tried to do, we need to set the alpha value. This alpha is the learning rate. What should be the step size? If you take a very slow, very less, your system may be very slow. What will happen? Maybe its memory and all is going to be so sluggish. Again, it's take a lot of time to reach this point. So again, selecting alpha is also a good thing, also an important thing. And this concept is the gradient descent. Algorithm. Okay, leave it. So let us start my approach. OLS method. Ordinary least square method. Okay. So what is your